Today we're going to have a look at the synthesizer I made already back in '04 or '05, and another project which is an analog mixer with digital control. And both projects I've worked already for a long time, but I never made a video of it that I put in public. So there are pictures, but the two machines here connected with each other, and this here board is the main part of the digital synthesizer. And we begin by putting it off. Little knob here, synthesizer off, and these boards too, this and this, put off, all off, no lights there, no lights there, and we're now locked off from this little board here, this board with this USB stick and this clock device, and here this network cable which runs back there to a 19-inch network cable here, which is connected to a normal router. No, a switch, actually, a giga switch. And this board is a Linux board. So if we fire it up, and we fire also this here up, which is another project with a toroid transformer supply. This chip here is a high quality audio volume control chip with its own dedicated supply, which normally contains this square in the square there in the middle of the board, if you can see that, which is a microcontroller, a 7020, and it has a slider, this slider, and that allows you to control while these wires are not catching any noise or hum because they're just a voltage. The microcontroller uses that voltage to set the digital value of the volume control chip, and then the input to the output receives a certain attenuation or a certain amplification from that chip. The output of that runs in here on the back of the power pack here. Here are the separation filters for the main amplifier, mid-highs, main volume, and the sub volume, and those are connected back there. That's not what this is about, so that's just a lot of amplification on the big speakers here with a sub 15-inch. And now I have connected another project, which is this project, the Linux board with the Ethernet, but not built further yet. Is connected via this band cable, where normally the microcontroller is connected to the volume control chip. And when this starts up, it will send a certain value which will appear on the display here, and that value is an hexadecimal volume value. And in this case, this board here, the Blackfin board, analog devices, is that's the digital synthesizer analog simulation. The output of it is connected via these pins here to these connectors, back here to the input of the volume, back into the separation filters for the amplifiers. That's all not important now, it's just that it's amplified properly and pre-amplified there with very high quality audio op-amps, probably the best audio op-amps in the world. The DSP board does a simulation, and it also has a MIDI input. The MIDI input is back here. Here it is. That comes from a programmable logic board, which is under here, hard to see, under the paper. That has a blinking light which says that it's working when it's on, and it reads the MIDI, and then it uses its own 24 bits converters to generate output. You can also take an input for the chorus. There's a chorus built in the synthesizer. And The design is on my website, www.thielware.org /synth. The whole design is open source. And so we're going to listen to this board being played by this general purpose keyboard here, which gets its supply voltage over the MIDI cable, which is connected back there as we've seen. And then this display is going to light up again with a number of parameters built in the synthesizer simulation. And this whole 19-inch and other enclosure arches to make sure that we have a computer-controlled volume, which is also interesting. So I will start that up now. First the volume, putting it on, we'll let the lights come on. And then we wait for this value here to change. C0, that means volume 0, like no amplification, no attenuation. That signal got sent by this FPGA board over this cable to this chip. And this Linux board has set itself up, started up, connected to Ethernet, read a TCL interpreter from this USB stick, and set this value by sending a signal to this FPGA board. There's also a display on this machine. I can show it shortly, but that's not done yet because the cool runner programmable logic couldn't give out enough current. I wanted a nice bright LED display, but that appeared not possible. We can now log in again. We shell into the Linux board there. Type the password. Check the time. Time. So not exactly accurate. It's just missed 15 minutes. Anyway, we start a simple script, a TCL script called slider volume. Where is it here? Slider volume. That gives us this slider. And if I now touch the slider, let's say I put it all the way down, then here we can read that the value that has gone in has become 0. If I put it all the way up, of course must be careful not to go too loud. Just for the sake of argument, hexadecimal value of FF on our board. And that went pretty well. I will change the values. You can see it changes rapidly. So let's put it at 100 or so. It's actually hexadecimal, of course. Now we can put on the synthesizer and we can watch the startup time. It starts up really quick. Push this button here at the left, and then you see the display come on and letters on the display and all the lights go on. Oops, I did it wrong. I'll do it again. And already now it says something here on the display. And there's a light blinking there saying the MIDI card is working that I made, and some other logic for the display. And this board here is active, green LED. And now we should be able to make a noise. Let's put it a bit louder. Change some parameter. Visible. This. instance, cutoff frequency, let's put it higher. Play a note. Or we can make the attack slower, for instance. Decay faster. Sustain a bit higher. Chorus is off. No detune. Maybe a bit of resonance, why not? Not as well. See what that sounds like. Now we can make a bass tone, for instance. Let's put it a little softer. The value changed. Faster attack. Slow decay. Detune, transpose it down 1 octave, lower cutoff, so much resonance. So. Put it on the tripod. More resonance, I'm counting it now. Some different values. Lower resonance, lower cutoff. Modulation, faster attack. And a little bit of chorus. I was turning the modulation wheel here on the left. Lots of chorus that gives. It's an impression.